Jesus Christ. Ah!
Oh, that's unreal.
Hey, my name is Bartosz, and in this clip I'm going to show you how you can do a prototype game in 30 minutes using Unreal Engine first-person template. So let's get right into it. All I did here is open Unreal Engine first-person template, and all I did is I removed the walls and these blocks that are there. And let's start with some cleanups. Let's get our first-person character and set it up at the middle of everything of our world, and also floor. And let's create first actor blueprint. It's going to be our enemy. Our enemy for now will get only a cube, and that's all. And let's create another blueprint class, another actor, and this is going to be spawner. And this is going to be spawner of our enemy. And let's go to the event graph, and at the begin play, let's set timer by event, and let's set it up time to 1, and let's tick looping. So let's get event at custom event, and let's name it spawn. So this event will trigger every 1 second, like we set it here, and it will do it constantly because we set looping. And let's spawn actor from class, and here we select our enemy, and we want to set up location of our enemies. What I want to do is I want to spawn our enemies around me in the random locations, but along the circle. So to do that, I'm going to use node rotate vector, and let's set it up x value of this vector at 1000, and then I will rotate it. This is in x. This is this. In this axis it got 1000 units, and I want to rotate it like this, so it will spawn, so it will set the location around me. And I need to rotate it in z axis, so I need to get random float in range, and the range is going to be between 0 and 360, so around us this actor going to be spawned. One more thing, our player character is at the level 266, so we want to also spawn in z-axis our enemy at 266, so it will be at the same level as we are. And so let's check if this works. Now it doesn't, because I forgot to place spawner in the level. Right. Always do that. Yeah. Here we are. Yep, it is spawning every second. But there is one more thing we can do. We can move this cube a bit up, because our actor has its origin point here, but the camera is here. So we want to spawn. We want to see the cubes at our side level, so we want to move up the cube a bit. Oh yeah, it's great. It's even a bit above, so it makes it more frightening. Great, now let's go to our enemies. We want to do something with our enemies. So we want our enemies to follow us. To do that, we can just interpolate location of our enemy to our actor. So, and we do it on tick, so every frame it will interpolate its location to ours, so it will basically follows us. To do that, we need to get location of our player, and we need to cast to our player, which is first person character, to get this info from it or any other info. And we do that on begin play, player character here as object. And now if we promote this to variable and name it player reference, we will have it. We will store reference to our player. So if we want to get any info about our player, we can just get this here and we can grab any info about our player in our enemy blueprint. So we want our player actor location and we want our enemy actor location. So this is our enemy actor location, target is self, and this is our player actor location. And then let's set location, set actor location, right. And let's do it on TIG, and here let's use winterp, which is short from vector interpolation. And current is our actor location, which is our enemy, and the target is our player location. And we plug delta seconds here, and we set up interpolation speed to 1. Let's check it out if this works. Yeah, it does. They are following me. Great. Whenever I go, they follow me. We can do one more thing. We can make our enemies always face us. It will so no matter we go, our enemy always will look at us. And there is nice note to do that. We don't have to do all the trigonometry. Unreal does it for us. Find, look at rotation. And also we need our enemy location and our player location. We already have it here, so I just copy it and plug it here. And set actor rotation. Yep, that's it. And start is our enemy, target is our player, exactly. And let's check. You see? Whenever we turn, this enemy always faces us. That's great. This is really cool. Okay, now we want to have some weapon, some protection against our enemies. So since it is first-person shooter, we can use our weapon to just kill them, destroy them. And here is our first-person projectile. We can open it, and here is event hit. We don't need to add impulse because we just want to destroy our actor. But we don't have to do it here. We can do it here. We can just get in physics. I don't know if you can see it. Now you can see it. On component hit, you can just get this. And if our enemy is hit but our projectile, we can get cast to first person projectile, and if it's true, we can destroy our actor. Let's check if this works. Yep. But our projectile bounced back, and we don't want that. We want our projectile to hit and destroy, no matter what it hits. We have only our enemies and our floor in this case, so whatever this projectile hits, we don't need to cast to anything. We can just destroy projectile. So we hit floor, it gets destroyed. We hit. You know what? I'm gonna switch off this fire sound because we're gonna use it a lot and it could be a bit annoying. We can switch it on later. Okay, as we speak about sounds, now we can add some sounds to our enemies so to make it more immersive maybe, or more scary. I got some sounds prepared, and this is it. As you see, these are loops. We create queue based on them. We open it. We select all the stuff. We have it here. We delete this default one, and if we select all of them and we pick a random node or any other node, it automatically connects all the nodes to it. And now if we play this node, it will randomly choose one of the 7 nodes. And we use looping node. So it makes loop of it, but it's not like one loop that goes all over again, but it is loop but made of random loops, so you cannot hear a pattern in there. And here are our attenuation settings. To set it up, here we can override attenuation, and all we want to do is we can change the linear attenuation distance to natural sound, so it will make enemies that are farther much more quieter than enemies that are closer. And one more thing we want to change is we want to enable listener focus. What it does is you can set up different volume of the things that are in front of you and things that are not in front of you, are from the side on back from you. So there is the focus azimuth cone, focus azimuth angle, and let's set it up to 10 degrees, which is very small. And there is non-focus azimuth, which is set up to 60 degrees. So there is non-focus volume attenuation, let's set it up to 1, and there is non-focus volume attenuation, and let's set it up to 0.5. So everything what is inside this 10 degrees cone, we hear at full volume, but everything what is outside of the 60 degrees cone, we hear at 0.5 volume, and there's smooth transition between this. So if we look at this, look at something, we hear it at full volume, but if something is from the side, we hear it only at half of the volume. And let's just go here, let's select this queue and just go here and add is as component. If we select the queue in browser, it will automatically add this selected component here, and it is set up to autoplay. Okay, it will make game more scary, but since we have basically only one voice of our enemies, what we can do to differentiate it, we can get it and change pitch to every instance of our enemy. So we can set pitch multiplier, and we do it at begin play. So we change the pitch for whole life of one enemy, and we get random flow in range between 0.8 to 1.2. Let's check it out. Yes, every enemy has different pitch. That's really cool. Now we can create some mechanics to count points for killing our enemies. And the best way to do it is to do it in our first person character, which I close unfortunately. Here it is. Okay, so since our enemy is already cast to our player character, and we store its reference, so every hit we can get to our first person character and we can add points, but we have to create these points first. So we create variable named points, and every variable by default is boolean, so we change it to integer, we compile it, and by default it's 0. So we go to our enemy and we get every hit we get from our this is first person projectile. We need to get our player reference, and we need get points, and we need to set those points. So we get our points, we add 100 to these points, and we set our points. And let's do it here. We have to display those points to our player. So let's create user interface. Let's just name it new widget blueprint. And let's open it. Here is a designer. So we get a text and we set it up here. Let's change its color to red, because these are gonna be half points, because we need that too. And let's change the font from to something bigger, yeah, like 40. Let's copy it, let's paste it. Okay, here we have it, and let's set it up health points to 100, because default value of our health points at the beginning will be 100. And let's copy once again and paste it. And let's set it up points. And these points, let's set its color to green, 100% green. Copy it again and paste it again. Yeah, and let's set it up to 0, because our points by default are 0. And this thing is our anchor point, which this is navigate to. So this lettering, which is on the left top corner, will navigate to the left top corner, but by default this is also navigate to the left top corner, and it shouldn't. It should navigate to right top corner. So no matter how the screen size is, this lettering will always be at the same distance to this corner as we set it up here, and this will be at the same distance to this corner. Okay, we have it. Since we are already counting our points, we can create a binding. So we get text, we create binding, and here we at the event pre-construct, which is something like begin play, we also need to cast to our first person character. Since we already did it here, we can just copy this and we can paste it here. And we need to create this variable here. So here we have reference to our player character, from which we have to take our points. Get our points, we plug it here, which is the display of our points we create here. Okay. We can't see anything. Why? Because we didn't add our widget to viewport. We have to do it in our first person player character at the begin play. So we have to create this widget first and add it to viewport. And our it is this. So let's check if we can see it. Yes. And it counts our points. Great. But we need make our enemy able to hurt us, so this game will be more interesting. So to do that, we won't use component hit, we use component actor overlap. So in our first person character, we need to change collision settings, and collision settings are by default set up to pawn. Let's set it up to custom, and let's set it up overlap all, with exception of word static, because if we need to block word static, because if we don't, we would fly down through the floor. So we overlap everything. And now we get our enemy, or we can do it in our in here, and we can just get our on component begin overlap like this. Okay. And if it's overlap, we get other actor and we cast it to our enemy, and we can decrease our health. So we have to create life variable. It is by default integer because the last variable we create was integer, and let's set the default value by 100, and let's also get a life and set a life. So every time we encounter with our enemy, we decrease our life by 1/4, by quarter, which is 25 points. And in our region blueprint, we also want to create binding here. Create binding, we get our player, get a life. Life, yeah, get a life widget, really. Okay, and let's check if this works. Yep, it works, even better than we thought. The problem is that we can't decrease our life under 0. So let's make a condition here that if this life is, it only works if this life is bigger than 0, and if it's not, it doesn't. But here we need to create another branch. We can do it different way. We probably could use only one branch, but for this case, let's do it like this. And if this life is equal 0, it means we are dead. So what we can do to make our death more epic, let's say, pun intended. But we want to do one more thing with our enemy. We want to make our enemy every time they encounter, they touch us, also die. So our enemy will be like a bee. So it will hit us and it will die. It will make this simpler because one enemy could overlap us many times, and we don't want that in this case. So when enemy hits us, it gets destroyed. And yeah, if 4 enemies hit us, we are dead. So what we can do here is we can disable input. We can disable input, and we can do one more cool thing. We can get post-process. We can plug it to our player character, get a global settings, get saturation settings, and set up saturation to 0. Yes, to 0. So our world is black and white. But we don't want to have our world black and white all the time. We only wanted to have it when we die. So we get this and we search for enable, and it is by default enable from the beginning. So we untick it, and we set enable here. Great. So now when we die, our world is getting black and white. But we want to do another cool stuff. We can slow the time, really. So we can use time, global time dilatation. There is node 1 is default, but everything what is below 1, it makes it slower, and what is above 1, it makes it faster. So let's set it up to 0.1, which is 10 times slower. But after a while, let's restart the level. So this is 0.2 seconds, but if we slow down time 10 times, this is actually 2 seconds. So let's say, let's display this death event by 2 seconds and then restart the level. To restart the level, we just open a level and we get name of our level. We don't want to open it, we just want to clone its name. I mean, copy its name and paste it here. Okay, there's one small thing we can do. We can add big red screen info. Maybe not you died, but something more encouraging, like maybe next time. Wink, wink. Really big. Yeah. And this anchor has to be at the middle. But we don't want it to make all visible all the time. We want it to make visible only when we are dead. So there is visibility, and we want to bind this visibility. So we get our player reference, we get our life, and if this one equals 0, we can select. So if life equals 0, that means we are dead. So that means we want to make visible true. And if it's false, we want to make hidden or collapse. It doesn't matter in this case. So let's see how our death looks like. Yeah. There's one more thing we can do with our enemies to make them more human, maybe, or to give them something anthropomorphic, so they are not only cubes, but they have some life in it. We can create material and we can make nice procedural animation in it. I have one simple texture here. It is like this. It is as simple as it gets. These are basically teeth. And what we want to do here is we want to do animation. So we get time. This is time that goes after we hit play from 0 through the time, and it display the seconds. And we get scene, which goes from 1 to -1, 1 to -1. And if we get texture coordinates and we split it to 2, and then we add this sign to one of it, and then append it back. We go to, you see what is going on here? It goes up and down, but the texture is tiling and we don't want that. So we get our texture and we set it up sampler source clamp. So you see it doesn't go, but obviously the movement is too big, so we have to multiply it by 0.25. Oh, we need to update those. And we need to add to it 0.25, right? Because I want those. No, we need to subtract 0.25. Yes. These are bottom teeth. And let's copy it. And let's create these are up teeth, but they are obviously too low. It has to be 0.25. Right? Right. So now, if we add it, we are almost there, but now what we have to do, we need to offset our sign, offset our movement. So we need to get our sign and just move it half of the period, right? So we need to add to our time. What do we need to add? We need to add half of the pi. So we get pi, which is 3.15, right? And we divide it by 2 because we want on half of the pi, and we add it. Yeah, it works. It looks like this. And if we multiply it by color, and we convert this color to parameter and we name it color, let's set it up to, for example, bluish. You see? And now we can get our enemy, we can get to our construction script, we can get our cube, we can create dynamic material instance. If we select this material, we can put it here. We can set vector parameter, and our vector parameter is color. And we can randomize it. So every enemy will have different color, which is cool. So if we set up this to one, HSV colors, and if we rotate our colors, if we change H value from 0 to 360, basically we rotate our color on the palette and we have every color we have. So we need to create this HSV, this one to one, this one to one, this one to one, and this one random float in range from 0 to 360. And let's check how our games look like now. We can do this more exciting if we go to our spawner, and every spawn we can update the time sequence, and we update it and we get seconds. No, not this. Get time seconds, I guess. Get time seconds. That's what it is. And we can map it unclamped. So at the beginning it has 0. And after 10 seconds, so at the beginning, let it be 1 second, but after 10 seconds it will get 0.5 seconds. So it will spawn enemies faster, faster, and faster, more frequent. Let's check it out. Jesus Christ. Ah! I'm dead. That's all. Thank you.
Oh, that's unreal.